All right, moving on to example 2, 4x squared plus 3y squared equals 48. This is an ellipse equation. X squared and y squared both the same sign. This is also an ellipse, x squared, y squared both the same sign. So they're both centered at 0, 0. We can have up to 4 points of intersection, so we'll see what happens. But if you imagine you have an ellipse, maybe the other ellipse does something like that, and all of a sudden you get 4 points of intersection. Or maybe you got like this, and the other one's like thinner and longer, you know. So, I mean, it's going to be one of those things probably. There's a possibility still that maybe you have one ellipse and here's the other ellipse, maybe you have no points of intersection, in which case you get an empty set. That happens sometimes. But again, graphing is not a requirement, but if you get an idea of what's happening, I saw the two ellipses intersecting. It could be up to 4 points of intersection happening there, so be expecting that type of thing. This time, elimination is a valid technique here because x squared, y squared, they match up. So I'd probably use elimination over substitution. In my opinion, elimination is always easiest when it can be used. So anytime it's available, I'm going to use it. I'm going to get rid of y. Numbers are a little smaller. We'll multiply the top equation times -2 and the bottom equation times +3. That'll make positive 6y squared, that'll make negative 6y squared, so the cancellation will occur. And if I shortcut this, I think we can handle the shortcut, but I'm going to get negative 8x squared and positive 9x squared. That makes a total of positive 1x squared. My negative 6y squared and my positive 6y squared cancel, and my negative 96 plus 105 makes 9. If you're not as comfortable with the shortcut, just get both expressions over here, both equations over here correctly written, and then just add like terms. You get the same result. When you use elimination on nonlinear systems, very often you get to this point, letter squared equals number. Be very careful if x equals plus or minus 3. Don't forget the plus or minus. You want to get all the answers possible every single time. Okay, so now if x equals positive 3 or x equals -3 are our two solutions for x, I want to go ahead and find y. I've got to go to one of my original equations. I like the bottom one better. Now it says 3x squared. So whether x is positive 3 or -3, if I go up, x squared is still equal to 9. So whether x equals positive 3 or -3, x squared is equal to 9. And that's really what I'm substituting in. So I only have to go through the process once. Just know that whatever answers I get for y, 3 with the answers for y and -3 with the answers for y. So whether it's 3 or -3, x squared is 9. I'm going right here. This is where I'm replacing. So 3 times x squared, which is 9, plus 2 times y squared, we haven't figured out yet, is equal to 35. 3 times 9 is 27. If I move that to the other side, minus 27, I get 2y squared is equal to 8, which means y squared must equal 4, which means y must equal plus or minus 2. Once again, letter squared equals number, letter equals plus or minus square root of that number. This answer for x leads to both of these answers for y. This answer for x leads to both of these answers for y. So we get 4 ordered pairs, 3 with positive 2, 3 with -2, -3 with positive 2, and -3 with -2. Each ordered pair is in XY order. Make sure that you got your variables on your paper so you know what's what, so you know the order that you're supposed to write those answers in.